Okay, so this is lesson 11.2C. So if you were paying attention, you noticed that when we did the two sample t-test option there, when you entered all the data, was to click pooled, no, or yes. So what does that mean? What is pooled procedure here? So there's two types of variance. So sometimes we have an unequal variance. This interval tests valid whether or not the population variances are equal, or we have equal variance procedures where assume the two populations have the same variance. This procedure would combine the terms or pool them to two sample variances to estimate the common population variance. The resulting statistic is called the pooled two sample t-statistics. We don't do that in APSTATs. So we don't pool the data. So when you're doing it on the calculator, never, ever, ever choose pooled data. We don't use that technique, but it is a valid technique. Okay, so today we're talking about paired t-tests for means. So I think we've done paired intervals, but these are paired tests. So it's all about the diff, right? So the null is the difference between the two. Is the hypothesis value. In other words, it's zero, right? The difference should be zero. There's nothing unusual going on, but there might be a direction to the alternate or not equal to, depends. The conditions are the same as what we had for the one sample t-test for means. So you only have to talk about the difference. You don't do each separate group. It's all about the diff here. So again, you have one column of difference that you're dealing with. So this is our formula. Again, it's very similar to the one sample t-test formula for t, but everything's about the difference. So the x bar, the mean of the difference, the standard deviation of the difference, and the n value of the difference. So you're pairing them so the n values can be the same for both. You can't pair data as an unequal number of folks. So it's just the n minus 1 would be the degrees of freedom. Okay, so this example we put down on your sheet. Researchers designed an experiment to study the effects of caffeine withdrawal. They recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. Each subject was barred from coffee, colas, and other substances with caffeine during the experiment. During one 2-day period, so it's a pretty short period of time, subjects took capsules containing their normal caffeine intake. During another 2-day period, they took placebo capsules. The order in which subjects took caffeine and placebo was randomized. At the end of each 2-day period, either with the capsules or without, a test for depression was given to all 11 subjects. Researchers wanted to know whether being deprived of caffeine would lead to an increase in depression. My first thought is, like 2 days and you're already depressed? I mean, I don't know. This seems pretty fast for depression to kind of kick in just because of caffeine, but let's see what happens. Higher scores. So again, they took the subjects with caffeine and without, right? There were 11 subjects, so N is 11. And we really need to find the differences between those two. So we have to choose an order. Is it caffeine minus placebo or placebo minus caffeine? We're saying that the difference will be greater than 0. And I'm assuming, did they say an order? They should say an order in there, like caffeine minus placebo, and just in general. So there's evidently something called a depression test score. Higher scores shows more depression. So if we wanted to be greater than 0, using evidence that the level of caffeine withdrawal increases depression. So increases. Oh, there it is. There's the order. So treatment placebo minus caffeine. That makes sense because we're thinking the placebo group might have a higher depression because they're not taking caffeine. They might get depressed. So if we want it to be greater than 0, we want it placebo minus caffeine. And so you define that variable, just parameter, just like we have. It doesn't say anything about the alpha level, or doesn't the question actually. So you'd say alpha equals 0.05. And then again, it's greater than 0 because we're taking what we think will be the higher depression minus the lower depression. Okay, so plan. So you would, check the conditions. So you look back and look for the random somewhere. It was randomized. The order was randomized, so it was random assignment. Less than 10%. So these 11 subjects are less than 10% of adults who are addicted to caffeine or have caffeine issues. And then you need to, the N value is only 11. We don't know about the shape of the population, so you would need to draw a graph of the differences here. So they did a histogram just kind of showing off, but you could just do a dot plot of the differences, but you have to find all those differences. So like for that first column of data, it'd be 16 minus 5 is 11. 23 minus 5 is 8. And so forth. So you just plot those values, the differences there. By the way, let me just mention this. So I don't know if we've done this yet, but it's pretty nifty if you needed to do this. So I'm going to just start a new document just so we have no extra variables around. So home, new document. So I'm going to list a spreadsheet. The first one is going to be CAF for caffeine, and then placebo for placebo, and then diff for difference. So I'm going to put the data in. So 5, 5, 4, 3, 2. And I have 11 pieces. I always like to check that. Wow, a lot more. 16, 23. Evidently, there may be some depression happening in just a matter of days here. Okay, so we have an equal number of data pieces. So in this third column, so I want to do the diff. So I want to do equals. We said the order was placebo minus caffeine. And they got bold because I typed them. They're variables. I'm referencing the variables. I put an equal sign first. So it'll calculate all those differences for us. So that's really the data I'm looking at. So if you did a dot plot, it would probably look something like this, right? And so it doesn't look majorly skewed, although it does look at least a little bit skewed, but not majorly skewed. And no outliers, we don't think, no obvious outliers, so that'd be okay. Okay. So just wanted to mention that your calculator can calculate those differences for you, or if you knew that or not. So then I would consider doing the test in your calculator at this point. So you add a calculator page, because really you want to get the standard deviation, the means, etc. So menu, statistics, and this is a test. And this is a one sample t-test. In the calculator, we just call it a t-test, a one sample t-test, not two sample t-test. And we are going to use data. We're calling that the null would be 0. We think the list is called the difference. Why isn't that an option? Oh, there it is. Okay. And then the alternate is greater than, we think. Okay. So we go okay. So it should give us all the data. Let's just see if that matches here with doing it by hand. So if you do this by hand, you got plug in all the numbers. So 7.364, that we got from the X bar there, the calculator, divided by a fraction. Standard deviation was 6.9177, divided by square root of 11, which is square root of n, equals 3.53, which is our t-value. Degrees of freedom, you would definitely want to write that on your paper. The things you have to write, the name of the test. You have to name the test, one sample t-test for means. The p-value is between, so the p-value is 0.0027. So you can get things out, p-value. I think they're using a table. That's why they got a range of values. Never use a table for that. So because the p-value, 0.0027, is less than the alpha of 5%, we reject the null. We have convincing evidence that caffeine withdrawal increases depression test score on average for subjects like the one in this experiment. So, wow, 2 days without caffeine, you might get depressed. Like, wow, that's a lot of, you're caffeine dependent, evidently. 2 sample T procedures require data that comes from independent random samples from the 2 populations of interest, or from 2 groups in a randomized experiment. The difference required paired data come from a random sample from the population of interest or a randomized experiment. So required you pair the data together. So it's not just like they have an equal number of data, but you have to pair them together by some similar quality. You either pick 2 similar people, 2 similar things, rank by age, rank by something else that makes sense, or you just do the same person, like a before and after with paired. So you're not taking the mean of the whole thing, it's each individual value, and then you get the mean of the differences. It depends. Sometimes it's impossible. Like we did the Chips Ahoy thing yesterday, and it'd be possible to pair that data. The Chips Ahoy with the Walmart brand, like how do you pair the cookies? There's no way to do it. So let's just look, which type is it? Is it a 2 sample t-test or a paired t-test for means? In each of the following settings, decide whether to use the 2 sample or the paired. Okay. Before exiting the water, scuba divers remove their fins. A maker of scuba equipment advertises a new style of fins that is supposed to be faster to remove. A consumer advocacy group suspects that the time to remove the new fins may be no different than the time required to remove the old fins. On average, 20 experienced scuba divers are recruited to test the new fins. Each diver flips a coin to determine if they wear the new fin on the left foot and the old fin on the right foot, or vice versa. The time to remove each type of fin is recorded for every diver. Is that paired data or 2 sample? And it's probably obvious. This is a great way to pair, by the way. So they're pairing with themselves, right? So one person is wearing on one foot the new style and on one foot the old style of fin. So you're pairing with yourself. So it is paired data, like we are comparing. And that's a great way to do it. Other than the fact that you might be, like I'm right-handed, I wonder if I'm right-footed. I think I might be right-footed as well. So like you'd have that going on, but if you randomly assign, kind of mitigates that a little bit. So I think it would be an interesting way to do things. So paired T, although how do you tell which fit is better? I mean, because it's interesting. I don't know. I have questions. Paired T procedures. The data comes from 2 measurements of the same variable. Time to remove the fin. Time to remove the fin. That's right. It's not how good the fins are. It's just the time to remove. That makes sense, actually. That is something we could time and could do that in the right left foot and, get some good data. So time to remove the fin is a thing, evidently. Okay. Second scenario. To study the health of aquatic life, scientists gathered a random sample of 60 white piranha fish from a tributary in the Amazon River during 1 year. The average length of those fish was compared to a random sample of 82 white piranha from the same tributary a decade ago. Okay. So what type is that? Maybe not as obvious here, right? So are we pairing the data? Like that first piranha we get, do we pair that with some other piranha from 20 years ago? Or are they paired together? I don't think they are, right? This is just a 2 sample T procedure. We're going to take, even though it's the same river, so that's the tricky part about it. It is the same river. We're not really pairing each individual fish with another fish from a decade ago, right? It's not happening. So they're in different years, different. I mean, I guess it could be. I don't know how long fish live, but if they live that long, it could be the same fish with itself, but we wouldn't even know. So not possible there to do a paired data. Can a wetsuit deter shark attacks? A researcher has designed a new wetsuit with color variations that are suspected to deter shark attacks. Okay, to test this idea, she fills 2 identical drums with bait and covers one in standard black neoprene wetsuit and the other in the new suit. Over a period of 1 week, she selects 16 2-hour time periods and randomly assigns 8 of them to the drum in the black wetsuit, The other 8 are assigned to the drum with a new suit. During each time period, the appropriate drum is submerged in waters that shark frequent, and the number of times a shark bites the drum is recorded. Okay, so did we pair like an individual wetsuit with another individual like new wetsuit? Did we pair them together? And the answer is we didn't. It's just 2 sample T procedures, right? There's 2 groups that are randomized. It's great, right? But this is not a paired data experience. So just recognizing what is and isn't is actually a really good thing. So do your homework and check out some of those problems. Make sure you can recognize which type it is. If you think about it, pairing it specifically, one thing goes paired with another. You can get this. That's the lesson for today.